Okay guys, welcome to Forensic Investigations. This is a session on email forensics, and what I'd like to do today is give an overview of some email systems, an overview of the email format, an overview of MIME messages, that's multi-purpose internet mail exchange messages, an overview of mail storage formats, and then we'll finish off with a little bit of encryption. So let's start off. The basic components you need for an email system are a client, and that is something that a piece of software that you're going to use on your computer in order to access the messages, so that is able to send requests to an email server to get access to those messages, and it's able to store and render those messages so that you're able to see them. And you also have a server, and that is able to send and receive messages, and it's then able to serve them up to your client. And there are a few protocols that are used for sending and receiving messages. So that is receiving messages from the server, or downloading messages from the server, or sending messages to the server to then send on to other mail servers. And one of those protocols is called POP3, which is a protocol that enables you to collect your mail. Another one is called IMAP, which enables you to collect your mail and also synchronize your mailboxes, perhaps across multiple clients that you're using, so that you don't have different emails appearing on different clients. And then SMTP, which is a protocol that is used to send email messages from your client to the server. And so what we have here is an overview of a mail server, and in our mail server we have some message boxes, and those message boxes are going to send and receive information through the POP and IMAP protocol, and they're also going to receive information through SMTP. It is possible that these messages are now encrypted in secure sockets layer, so that they're unable to be read by people who are intercepting them. Now, you will have a client computer of some kind, and that client computer is going to have some software on it that is able to fetch emails and also able to send emails. And it's going to be fetching emails using POP on IMAP, and it's going to be sending emails using SMTP. You will also have another mail server, and that other mail server will be no doubt receiving emails, which is then able to pass on to its clients. So that's an overview of how email works. Now, for all of you who have access to university email is actually based on Google. And Google, of course, has a web page that you go to, so your web page is your client, and that means that on your home machine you're not actually downloading emails, and you're not storing any emails, so the sort of forensic evidence you're going to be able to pick up is very, very different. We'll come to that at the very end of this session. So the SMTP protocol enables you to send mail to a mail server, or between mail servers, to enable messages to get from one mail server to another. It is a text or an ASCII only protocol, although it does permit binary characters, so there's a mechanism whereby we can encode binary characters to make it look as if it is ASCII text. It will contain information with regards to who is it from, who is it to, and what is the data of the message. And we can have a quick look at a message here. So what we have is a machine that Gareth owns, and Gareth is using the Telnet application in order to connect to port 25, as we can see up here. So we are connecting to the SMTP server of the University of Portsmouth, which happens to be running on port 25, and Gareth is then able to generate an email message with a mail from dr.garethowen@gmail.com, with a receipt to garethowen@port.com, and then the data of that particular message. So I can enter into a subject line, enter into the contents of the message, and then send the message and quit. So that's a general interaction that one might have with an SMTP server. Of course, mail clients are not terminal window. You're not using Telnet as a mail client. That's incredibly inefficient. This gives an overview of the steps involved in using an SMTP server in order to send an email message. And here's an example of that message actually being received. So this is Gareth actually receiving that message. The email message structure contains two things, which you may not see very often now that you're using web-based clients, but you're going to have a header, and that is a series of information, the to information, the from information, courtesy copy, blind copy, dates, what servers this email message may be transmitted through. And it also contains the body of the message, and the body of the message will be sort of plain text information. It will often be also in MIME format that enables you to send text information and also any attachments to the email message. So those attachments can be received and rendered by the recipient. So let's have a quick look at a real email and some headers. Now we'll start off with our common header, which is to, from, and subject. We'll also have some dates and some times. There may be a series of paths across the internet. There may be an identifier for whoever has generated this email. And there may be some originating IP for web-based email which identify the sender IP address. All of these, of course, are very easy, as we've just seen with Gareth interacting with this SMTP server here. All of these are relatively easy to fake. He could have said that this email is from whoever he likes. So none of it is actually to be considered absolute. Now, we are able to send some binary data. So the MIME format specifies how the message will be structured, so that it can include a variety of different attachment types and also include HTML. And those attachment types may be encoded using something called base64. We'll get on to base64 in a little while, but base64 is basically a way of converting binary data so that it looks like ASCII data. And the way that we can do this is because ASCII doesn't actually use the most significant bit, and our base64 encoding, we're only going to use 6 bits in order to encode individual letters. It does make the data longer because in essence we're using 8-bit data. Well, in essence at the moment we're using 8-bit data, but we're actually representing it with fewer bits, but we'll see how that works in a little while. I also have some email messages as well on my system that I wanted to have a look at, and so here are some email messages that have been retrieved from a server, and if I just open this up, it gives you an idea about information that's included in the header. So this part here is my header, although it isn't explicitly stated here. It's got my message ID, the date that this was sent, my from, my to. There is no subject. The multipurpose internet mail exchange version, so MIME version 1. The content type is plain text. This is an idea of what character set we're using. This is the encoding technique that we're using. This is the person who has sent the message. This is where it was sent from, and then we have the information that that was contained in the body of the message. So I think I also have another example email here. This one's slightly more recent in that we actually have the message being encoded with boundaries, and so we have the header here, which is very easy to see. starting at my date and then ending down at 7-bit down here. And in my header I have specified the content type is multi-part mixed. Sorry, Gareth has specified that the content type is mixed, and that the multiple parts of this email are separated by a boundary that's indicated by this signature. Now you can see that this signature is identified here. It's also identified here, and we come down to another part of the body, where this body happens to be a content type which is specific to an application. It has a particular file name, and it happens to be encoded using a technique called base64. So this may be something that you're able to extract out of some mail client that has stored this email data. It may be something that you're able to extract from a mail server. Now, MIME encoded information, you'll tend to see the content type for emails that are sent with other types of data, so attachments of any other type. You will tend to see that as being multi-part mixed. There will be a message with multiple parts. That multiple part, as we've just seen, is split up by this frontier, by this particular signature here, and you may see commonly that the attachment, so the other information that's contained in the body of the message, happens to be base64 encoded. So what is base64 encoding? Now here's an example which looks really odd, and the reason for that is because in this example, which as Gareth states is shamelessly taken from Wikipedia, we are taking ASCII characters, detailing them in ASCII format, and then randomly changing them to base64, which feels really, really strange. So what have we got here? Our text content is man, so MAN. Our ASCII, and this, off the top of my head, this must be decimal, so this is the decimal version of our ASCII code. And then we have the binary of this particular decimal number, and we've just put our bit pattern, put our binary numbers contiguously across from left to right, and we're then for base64 encoding, we're just going to divide this bit pattern up into 6 bits, and with dividing it up into 6 bits, that gives us a certain number of possible combinations, and those combinations, well, you can probably guess we have 64 combinations, and those are there and mapped to particular characters. So in this case, we're able to see, okay, we'll start off with this 6-bit pattern 110010. If we convert that into decimal, that makes 19. Let me just check that. Yeah, that makes 19. And then that is encoded using base64. So that is equivalent to the character T in our base64 encoded table. And we then take the next 6 bits, which in decimal is equal to 22, and then that is, you're able to encode that 22 as being capital W. We then have 5, we then have 46. Now what this in essence means is that our text content that we're sending here is encoded using ASCII. That ASCII is then split up into its bit pattern, which we then recode and are able to present back as text. So we can transmit this directly as text, and you can see, because instead of having 8 bits to represent each letter, we now only have 6 bits to represent each letter. Our text is now going to be 4 characters long. However, if this happened to be, I don't know, some application, some picture or whatever else, then we are able to take our 6 bits, map them to a particular ASCII character, and then transmit those characters as base64 encoded information. Now, the POP protocol, which you shouldn't find used too often nowadays, is a protocol that's used to pick up mail from a mail server. It's a protocol that doesn't perform any synchronization between whatever mail client you're using and the mail server. You'll notice now on your phone that whenever you look at email and delete email, you then go to a client on your computer, and the email that you just deleted on your phone is no longer available for you to see on your inbox or whatever directory you deleted it from on your computer, on your laptop or whatever. And with POP it was. So actually functionally is I really didn't like POP. You would delete an email from one place and then it wouldn't get deleted elsewhere. Anyway, here is the overview for how POP works. We're waiting for a connection on TCP port 110. We're then able to connect to the POP server. We pass in a username and a password. At the top of my head, using the POP protocol, these are actually transmitted in plain text, which is never a good thing. This is accepted, and then that's deemed to be authentication to get access, in this case, to ONG's mailbox, and then is able to send those messages that are new to the client that are receiving these POP messages. So that's a little bit of an overview of how POP works. And once they're stored, once they're received, these messages may well be stored by the mailbox on your home PC into a variety of different folders according to whatever client application you happen to be working on. Now, you're normally able to see, so most mail clients have standard sort of read, forwarded, flagged, deleted, in, new. There are some standard folders that you would tend to find that have been made by the email client. So that covers a little bit about storing emails. The format of your messages may be slightly different between the mail clients that you're using. So I believe that you have had exposure to Thunderbird mail client either through the laboratory here or previously. So you'd have seen how Thunderbird has stored email messages that are being received as a mail client. So there is this standard mbox format. All messages are appearing one after the other. The from note denotes a new message, and there's a whole variety of metadata which is generated by Mozilla when you're using Thunderbird as a mail client. There is a mail directory, which is a standard format that should be adhered to. That mail directory should have some underlying folder structure, and then individual messages are then just treated as individual files, and we're able to move into a file structure with our mail structure that we're used to. So we have directories, we have files, we have generated times, we have times that those files have been written, times that those files have been accessed, and times that those files were originally put onto the system. There are other clients that other email client settings that may need to be looked at, and in the case that you've seen, passwords may be encrypted. If there's no password for the encryption, the key may be stored somewhere unprotected. That's a little bit of an assumption, but on most computer systems that you may find that. I don't know, particularly for the image that you're working on for this laboratory. Oh, what about web clients? I mentioned at the very start of this presentation, web clients, of course, you're interacting with email through a web browser, and so therefore you're not leaving that many artifacts on the computer system. So the only thing you've got is the fact you access that, you've got cookies. I mean, if you copy your email onto a file and save it, you'll have that, but aside from that, you don't have anything else on your system. Gmail supports offline, so it means that you're able to use local storage to store messages so they can be accessed offline should you wish to do that. But aside from that, if you're using a web-based client, almost all of the information about your email, of course, is going to be on the web server that you're accessing your email through. Now, email encryption is something that is rarely used. There is something called Secure MIME. It's on the standards tracks. As Gareth says, support is flaky. Webmail systems don't support it. Gmail doesn't support it. In fact, getting encryption through Gmail is awful. You can, of course, write a message, encrypt it, put that message into an email and then send it. That's assuming that the person at the other end has the ability to extract the message and decrypt that, so they're able to have access to a key that is going to be able to decrypt it. And one of the mechanisms that you could use to do that is something called PGP, Pretty Good Privacy. It is open source, it's been around for a long time. There is a plugin for some clients. As Gareth said, it's famously used by an Italian paramilitary organisation. And there are a number of stories from around the world where police have been unable to access files or emails that have been encrypted with PGP. PGP is an asymmetric encryption system, therefore it's going to generate two encryption keys, one being a public key, one being a private key that you need to keep safe. Everybody else, if they want to communicate with you, should use your public key, which you can then decrypt the private key. If you want to send an email message to somebody else, you can encrypt it with their public key, which they're then able to decrypt with their private key. That means that no one else can read it. If you want to send a message that they need to verify has come from you, you decrypt it with your private key, but then everyone who has access to your public key, aka everybody in the world, because everybody should have access to your public key, or you assume everybody does, then you can verify the messages from you, but you don't keep that message, the message contents hidden. There's an encryption structure which utilizes something called certificate authorities, CAs, and it is possible to use something like a certificate authority in order to verify your encryption keys to be used for email. And well, Gareth states here, if you don't use the use of unauthenticated keys makes man-in-the-middle attacks possible. I mean, that is entirely true. If you don't have a third party that's able to verify that the key belongs to who you think it belongs to, then of course anyone can come up saying, hey, I'm Bob, please communicate with me using this key, which is Bob's key. And that gives you the ability to decrypt anything that they happen to send to Bob, thinking that they have actually got Bob's key. So that was a little bit about email. So generally, well, emails are text-based systems. Binary can be added. There's a fairly complicated technique to add binary information to emails, which is called base64. I do suggest you spend some time looking at that. There are many mailbox formats, but mbox and maildir are very common. Encryption, of course, encryption anywhere can thwart forensic processes if the keys are unrecoverable, because the whole point about encryption is you're not only able to access the information if you don't have the encryption keys. So, thank you very much for listening. Cheers.